So yesterday we talked about the six number sets. Today, and we talked about operation, plus, minus, or addition, subtraction, multiplication, and division. And today we are going to continue that discussion and talk a little bit about order of operations. Let me double check on the syllabus. Kind of changed it a few times, so I want to make sure I've got the up-to-date one here. Yep. Okay. So when we think about operations, remember yesterday we talked about adding, we talked about subtracting, we talked about multiplying, and we talked about dividing, right? These two here, multiplying and dividing, are kind of inverses of each other. So what do I mean by that? What I mean by that is that if we look at a simple multiplication problem, if we say 2 times 3 is 6, the inverse operator is kind of, you can think about it as going the other way. So 6 divided by 3 is 2. Okay. You could also look at it as 6 divided by 2 is 3. So it's sort of an inverse of the original direction. Okay. 2 times 3, yesterday we talked about how that is 2 added to itself 3 times. 2 plus 2 plus 2. We also talked about how if you have 2 to the third, that is 2 times 2 times 2, right? Very different from 2 plus 2 plus 2. This is 2 times 2 times 2, which would be 8. All right. Any questions for anybody that tried the homework from yesterday and today? Any questions on the homework? Any problems that you want me to do for you while we have a few minutes before we get into everything else? All right. Okay. So let's talk a little bit about then order of operations. All right. Order of operations. The first thing to understand about order of operations is this order is not mathematical in nature. This is what we call a convention. Okay. And something had to be decided because if you have, for example, all right, this, and let's say we just did it from left to right. Okay, and the first thing I did is I added the 2 and the 3. Well, that would give me 5. Then if I multiply the 4, that gives me 20. But if I come here and I do the multiplication first, hold on, I got a message coming through. Where can we find the homework? I had trouble finding it last night. Um, it was sent to the email that we have on file. Um, so let me double check here to the person that asked. Um, all right. So here, if we do the 3 times 2, or I'm sorry, the 3 times 4 first, okay, that would give me 12. And then 2 plus 12, that gives me 14. So this creates a problem. We have to decide, mathematicians have to sit down and decide what order do we do the operations in. It doesn't really matter what order we do it. We just need to all agree that we're going to do it in the same order so that we can communicate back and forth, so that everybody executes this the same way. Okay. Hmm. So, what they came up with was known as the order of operations. And the order of operations has an acronym. And I'll explain this acronym. So, in your notes, just write this PEMDAS. Okay. P stands for parentheses. P stands for parentheses. We do whatever's inside the parentheses first. E stands for exponent. So if you have a number with an exponent, you do the exponents second. Next, you do all of the multiplication and division left to right. Now, sometimes order of operations is taught this way, and this is incorrect because it gives you the idea that you're supposed to do multiplication first before division. When in fact, if you have two numbers together that are, um, hold on a second, let me think about this. So if you have, obviously this is multiplication first, then division, so that's easy. But here in this case, where I have division first right next to multiplication, okay, if we were to follow this convention that's sometimes taught, you would do the multiplication first, 8 times 4, and then 2 divided by that. And that creates a problem. We need to do multiplication and division left to right, which means I do the 2 divided by 8 first, and then multiply by 4. And it works the same way with addition and subtraction. We do those from left to right. So you may have subtraction first before you have addition. So we would do this first and then add the 4. We would do the 5 minus 4 first, and then we would add the 4. So left to right when it comes to multiply, divide, add, and subtract. All right, so let's look at a few examples of this. All right, so here we have parentheses, 8 minus 2, and that's carried to the second power. And then we have 4 minus 2. Now, when I have parentheses next to each other, that means multiplication. So, just like we talked about yesterday, multiplying can be an X, it can be a dot, it can be a parenthesis, right? So this is 5 times 2, this is 5 times 2, this is 5 times 2. You can do one parenthesis and no parentheses. You can do no parentheses and one parentheses. Each one of these right here communicates the exact same idea, 5 times 2. And it's important to notate that because we need to understand what operations are being done here. So in this case, it's saying, hey, whatever this ends up being, we're going to multiply that by whatever this ends up being. So if we remember our order of operations, we do what's in parentheses first. So inside this parentheses is 8 minus 2. So that gives me a 6. And inside this parentheses is 4 minus 2. And that gives me a 2. All right, so we're done with parentheses. Next are exponents. And I have one exponent, 6 to the second power. So that is 6 times 6 times 2. Okay, 6 times 6 is 36. Now, all I have left is 36 times 2. Hello, George. I'm going to work out 36 times 2 here. So 72. All right, let's do another example. Here we have all right, 8 minus 9. Then we have a big line, 4 plus 3, and then times 2. So what's going on here? Now, a line like this is just like a fraction. So you've seen fractions before. You've seen 1/2, 3/2, 1/3, things like that. What does this line here? This line here is known as a vinculum. And it simply means everything above it is in parentheses and everything below it is in parentheses. And then this line means division or quotient. So this literally says the quantity 8 minus 9 divided by the quantity 4 plus 3 times 2. Now you'll notice a word that I just used, and that is the word quantity. When we communicate math, and you have parentheses, parentheses are denoted verbally by the word quantity. And this is important because if I said out loud without writing anything down, the quantity of 8 minus 9 divided by the quantity of 4 plus 3 times 2, you would be able to replicate what I said here. Because if I just said 8 minus 9 divided by 4 plus 3 times 2, you might write this. 8 minus 9 divided by 4 plus 3 times 2. That's very different from this. Because if I say it out loud and don't write it down, I need a good way to denote where I'm putting my parentheses. So the way that I do that is I use this word called quantity. The quantity of 8 minus 9 divided by the quantity of 4 plus 3 times 2. So let's work that out. 8 minus 9 is 1 divided by 4 plus 3. That's 7 times 2. Now, notice that I have division and multiplication. So if we look at our acronym again, right, we did the parentheses first. We do not have any exponent, so now we're on to multiply and divide. Now, here, normally people would look at this in the original way that I was taught, and I would have done 7 times 2 first, because the m comes before the d. And this would have ended up being 1 over 14. And that is actually incorrect. What this is supposed to be is 1 divided by 7 first, then multiplied by 2. So this ends up being 2 times 1/7 is 2 over 7. So a vastly different number, 1/14 versus 2/7. So let's break this down a little bit because I kind of did some things here and I want to make sure that we understand what's going on. And if you do have a question, you can either message me directly through the chat or just turn your or unmute yourself and ask it out loud. But I want to point out a few things here. First, we'll see that we did have addition and subtraction, but we never really made it all the way down before we got to our answer. And that's because of the parenthesis. When we look inside parentheses, okay, you kind of start all over with the order of operations. And so when I look inside parentheses, I'm ignoring everything else, and I'm looking at just this 8 minus 9. So in this case, that's just one operation, so we don't have to worry about an order. But we'll start doing some problems here in a minute where we'll have several different operations inside parentheses. So when we say to go inside parentheses first, once we go inside, we will then need to exercise through our order of operations inside the parentheses. So that was kind of the first issue. Obviously, we did do subtraction, we did do addition, but we didn't wait to do them at the end. We did them early because we went inside the parentheses first. All right. Next, I want to work this out again without using the division symbol, but keeping the vinculum right there. Okay, so I'm going to rework this in the same way, but show you a little bit different way to do it. All right. So here, because this implies parentheses above and parentheses below, I can go ahead and do what's inside the parentheses here and inside the parentheses here. And this is an important point. One of the hardest parts about math is the things that are not written down. So when we use a vinculum like this, it eliminates the parentheses. So when you look at your order of operations, you think, oh, I don't have any parentheses. You actually do. This line right here implies parentheses above and parentheses below. And there's going to be a lot of things like this that I will point out in algebra as we go forward, things that are not written down. And so it looks like a rule is being violated, but the rule is not violated. You just need to understand what's not written down that's still there. Okay, so let's do what's on top first, the 8 minus 9. That's and oh, I said 1 last time. I'm so sorry. That should have been a negative 1. So that should have been negative answers. I just saw that. Sorry about that. All right, so we have a negative 1 over 4 plus 3 is 7, and then times 2. So right there, we are dealing with the same thing we did before. Negative 1 over 7 times 2. That's negative 1 divided by 7 times 2, or what I rewrote here, negative 1 over 7 times 2. All right, now when we multiply a fraction by a number, all right, that's not a fraction, we need to represent this number as a fraction. So how can I represent 2 as a fraction? Well, that's easy. I can just do 2 over 1, right? 2 divided by 1 is still 2. So I have not changed anything, but I am expressing this as a fraction. And that's important because when I multiply two fractions together, I multiply the numerators together, and then I multiply the denominators together to get my answer. So negative 1 times 2 gives us a negative 2, and 7 times 1 gives us a 7. So here we can see again why this negative 1 over 14 would be the wrong answer, and why the negative 2 over 7 is the correct one. All right. If you have a question, just go ahead, like I said, unmute yourself. Otherwise, I'm just going to move on to another example. All right, now I want to get some slightly more complicated ones that work out even. So I'm going to bring up something real quick. Okay. All right, let's do 7 minus 5 divided by 3 minus 5 minus 4. Now we're going to have nested parentheses. Okay, I'm going to go ahead and write off to the side order of operations. So if you need to write that off, do that for yourself. That way, whenever you're working the problems on the homework, you'll be able to have a quick reference there. All right, so first things first, let's look at parentheses. So I'm going to look at these parentheses, look inside there first. 7 minus 5 is going to give me a 2. All right, then I've got my divided. Now check this out. So if I look inside these parentheses, I've got 3 minus the quantity 5 minus 4. So this is a good example where as I look inside these parentheses, I have subtraction and then I have parentheses again. Okay, so what I need to do here is I'm starting all over. So 3 minus 5 minus 4, let's start at the top. We're going to do parentheses first. So I'm going to go inside these parentheses now, and I see 5 minus 4, and that's 1. So I'm going to do 3 minus 1. All right, so now I've got something slightly more or slightly easier. So now what I'm going to do is I'm going to start again. Okay, where am I at? I've still got parentheses, so let's go back here to the top. The parentheses, 3 minus 1, so that's a 2. So I've got 2 divided by 2. All right, I'm done with all my parentheses. I don't have exponents. I don't have multiplication. I've got division. 2 divided by 2, that's 1. And I don't have any addition or subtraction left. So the answer to this one is 1. Any questions? Good. All right. I'm going to do 5 times 4 minus the quantity 6 minus 3 to the second power. All right. So here we can write out our order of operations. We start with parentheses. I look inside. I know I have an exponent here, but I'm not doing exponents yet. I'm ignoring everything else, only looking what's inside the parentheses. That's 6 minus 3. So I've got 5 times 4 minus 6 minus 3 is 3, and that's raised to the second power. Make sure I wrote that down correctly. Yep, second power. Okay, now I don't have any parentheses left. I've got multiplication, I've got subtraction, and I've got an exponent. The next thing I do is the exponent. So I've got 3 squared. So 5 times 4 minus 3 squared, or 3 to the second power, is 3 times 3, which is 9. So 5 times 4 minus 9. Next, I've got multiplication and subtraction. So I'm going to do my multiplication first. 5 times 4 is 20. And then I have minus 9. So all I have left is one more operation, 20 minus 9. And that leaves me with 11. All right. Let's do one a little more complicated. We're going to do the quantity 3 squared minus the quantity 2 plus 1 plus 3 times 2, and then divide that by 6. All right. So whenever I have multiple parentheses, sometimes it helps if we take the parentheses. We know that this is a quantity, and we're going to look inside parentheses. Sometimes it helps if we draw a box around what our parentheses are. And the reason why that's helpful is it kind of draws our eye toward the parentheses that go together. Now this one is not super complicated. There's only 2 sets of parentheses nested together, but sometimes you can have 3 or 4 sets of parentheses all nested together, and it can be a little bit difficult to intuitively just kind of see what goes with what. So draw boxes around the things that go together, and that might make it a little bit easier for you to see that and execute well. All right, so if we put up our order of operations, start with parentheses. We have these outer ones, so we're going to look inside there. We're going to ignore the divided 6, and then we have another set, so we're going to look inside there since that's inside, and ignore everything else. 2 plus 1. So that's going to give me a 3. So I have 3 squared minus 3 plus 3 times 2, and then all that divided by 6. All right. Now I'm going to go inside these parentheses because I still have parentheses, so I need to go back to looking at my parentheses. Then when I go inside here, I am going to look at what operations I have. I have an exponent, I have subtraction, I have addition, and I have multiplication. So my exponent is what I'm going to do first, 3 squared. So that's 3 times 3, that is 9. Okay, minus 3 plus 3 times 2. Now I'm going to keep the parentheses here because I'm still working inside, okay? And once I've executed all of the operations, that's when I can remove the parentheses. So notice here, the parentheses were around 2 plus 1. After I executed that operation, then I put the 3 here. There's no parentheses around it. So once we get this thing down to one number, then we'll be able to take the parentheses off. All right, so I have subtraction, addition, and multiplication. So we are done with exponents. Now we're on to multiplication, division. I only have multiplication, so I'll do that next. So I've got 9 minus 3 plus 6. Now inside the parentheses, I have addition and subtraction. I need to do that from left to right. So I don't want to do the 3 plus 6 first. I want to do the 9 minus 3 first. So 9 minus 3 is 6. 6 plus 6, that's 12. Now that I'm down to one number, I can remove the parentheses. And then I'm left with 12 divided by 6, which is 2. All right, that one was slightly more hairy. Any questions on that one? You guys are rock stars. Good deal. All right. So what I'd like to do is go slightly more complicated. And we'll do 5 times 3 minus the quantity 15 divided by 5 minus 2 times 3 times 3 minus 2. All right. Put out my order of operations out here. All right, first things first, we're going to go with parentheses. And then inside parentheses, I have division and subtraction. So the division is first. 15 divided by 5 is 3. And you'll notice that I'm doing one operation at a time. Until you get really good at order of operations, I recommend you just do one operation at a time because that's the number one way that students make mistakes in basic math is rushing through the order. All right, next I've got parentheses right here. So I'm going to execute that. 3 minus 2 is 1. So I've got 5 times 3 minus 1 times 3 times 3 minus 2. Right. Now I have dropped my parentheses. I do not have exponents, so I'm on to multiply, divide. And I've got multiplication here, here, and here. So I know I can make this a 15 minus 2 sets of multiplication. I'll just go left to right. 1 times 3 is 3. 3 times 3 is 9 minus 2. So now we just pretty much have subtraction left. 15 minus 9 minus 2. And so you could just, that's going to be 4. You can do it one at a time. You can say 15 minus 9 is 6, minus 2, and then do your 4. But I think you guys get the idea. Right. Let's do these now with fractions. Start off simple. All right, so we're going to do 1½ divided by 2 4/5 times 5/3 minus 1 5/6. All right, so first things first, and I'll demonstrate this with this one right here. Let's talk about visually what 1½ is. So if I look at a circle and I divide it in half, what do I mean by 1 1/2? We understand here that 1 1/2, we have an and, right? So 1 would be an entire unit. And then and the half would mean half of the same unit. So in this case, I have a circle. So I have a whole circle and a circle of the same size, even though I didn't really draw it that way, half of the same type of unit, 1 1/2. Okay, but it works with any type of unit. If you have rectangle, you have 1 1/2 of the same size rectangle. Okay, that's what we mean. And the reason why that's important, if I take the circles here, because it's a little bit easier to visualize. Okay, let's assume these are exactly the same size. 1 1/2, notice how that's, you have a half here, a half here, a half here, and a half here. What I have are 1, 2, 3 halves. So 3 halves is the same thing as 1 1/2. Okay, so let's go over some terminology when it comes to this. 3 halves and 1 1/2 are the same thing. This format, where you have 3 halves, is known as an improper fraction. It has the word improper because notice how my numerator is bigger than the denominator. Okay. This expression here, which is the same thing, is known as a mixed number. Mixed number. And it's a mixed number because we have two numbers together that represent the idea. So here we have 1 1/2. Here we have 3 halves. It's the exact same thing. So obviously in this particular problem, I have mixed numbers on top and bottom. Now, when we're dealing with order of operations, it's a lot easier to deal with manipulating fractions when they are in improper fraction form. So the first thing I'm going to do is I'm going to go through here and change all of these to an improper fraction. Now, how do we do that? Do I need to come here and I need to draw out, well, for example, here, do I need to draw out, actually, this one right here is in improper fraction form already. I just noticed that. But if we look at this one, do I have to actually draw 4/5? Okay, so if I do a circle and I'm going to do fifths, so that's going to look something like 1, 2, 1, 2, 3, 4, 5, right? So I'm going to have 2 of those. 1, 2, 3, 4, 5. Wow, my drawing is terrible, but I think you guys kind of get the idea. 1, 2, 3, 4, 5. There we go. All right, so two units, and then 4/5 of a unit. So that's 5/5 here, 5/5 here. So that's 10/5 plus 4. Okay, so that's 14/5. That's a lot of work. So there's a mathematical way that we can go into a mixed number and change it to an improper fraction. We know that these two wholes are right here and right here, right? This right here is 5/5. This right here is 5/5. So we know that the denominator is going to be fifths. And I know that two wholes is going to give me 10/5 because I'll have 5 here and 5 here. Then whatever I have over here, that's the other part of my mixed number. I just have to add that. So adding that 4 would give me 14. So sometimes you see this written as 2 times 5 plus the numerator. 2 times 5 gives me 10, plus the numerator 4 gives me 14, and then I put that 14 over the 5. Now, one thing I never do with my students is I never just teach them how to do that math trick. I always want to show you why that works, okay? Because you have 2 of these fifths plus 4 of the fifths. So 2 times 5 plus 4. It's always important to understand where those math shortcuts come from. All right, so I've taken up a lot of room. I'm going to move to a new sheet of paper. We're going to continue the same problem. All right, so 1 1/2, we know was 3 halves. And then down here we had 2 4/5. We changed that to 14/5. And then we're going to multiply that by the 5/3 was already in an improper fraction. And then subtract, I have 1 5/6. Okay. So 1 5/6 means I have one whole, which is 6/6 plus 5. So that's 11/6. The other thing I can do is do 1 times 6, which is 6, plus 5, which is 11. 11/6. Okay. So now I have everything in improper fraction form. Okay, so I have a vinculum. What does that mean? That means I have parentheses on top and parentheses on bottom. Parentheses on top don't matter because there's no operation other than the 3 divided by the 2, but that's a fraction that we're going to leave like that because that doesn't simplify. Okay, so we're just going to leave it. Then down here, we have these two parentheses, and so we have multiplication and subtraction. So we're going to do the multiplication first. So I'm still going to keep my 3 halves on top. And then here I'm going to have 14 times 5 in the numerator, and I'm going to have 5 times 3 in the denominator. So let me work out 14 times 5 here off to the side. Okay, that's 70 minus 11/6. All right, so now I still have parentheses on the top and bottom. Top again doesn't matter. But now notice that I am subtracting two fractions with dissimilar denominators. What does that mean? That means the denominators here are not the same. So I have to find the least common multiple of 15 and 6. 15 and 6. So an easy way to always do this is just to multiply the 15 and 6 together in order to get a common denominator. But sometimes, like in this case, there's a lower number that we can use. For example, if I double 15 to 30, 6 times 5 is also 30. So I'm going to use that because that'll be simpler. But again, you can always just use 15 times 6 here or 6 times 15 there. Okay. So what do I mean by all this? And a lot of you know this already from working with fractions before, but I just kind of want to highlight this because it's a good review. I have 70 over 15 minus 11/6. Okay, so in order to get a common denominator, I'm going to multiply this 15 by 2. Now, I can only multiply this 15 by 2 if I multiply 70 by 2. And why is that? Because 2 over 2 is just the number 1. So I can come in here and I can multiply 1 times this. I can multiply 1 times that. I can multiply 1 times this. And it gives me back the exact same thing. I haven't changed anything. So all I'm doing is I'm using the number 1, but I'm expressing the number 1 as 2 over 2. And I'm doing that specifically because that's going to give me 30 in the denominator. Here, I want to multiply that 6 times 5. In order for this to be 1, the numerator also has to be 5. So 5 over 5 is 1. Excuse me. So now, I'm going to use another sheet of paper. All right, so we have 3 halves up top, and then here, all right, we had 2 times 70, which is 140 over 30, minus 5 times 11, which is 55 over 30. All right. Now, since these two have a common denominator, what I can do is I can combine the numerators. 140 minus 55 over 30. Now 140 minus 55, that's 85. So I have 3 halves over 85 over 30. Now, 85 over 30 can be simplified. 85 over 30 can be simplified. I can divide the top and bottom by 5. So if I take 85 and divide it by 5, that gives me 17. And if I take 30 and divide it by 5, that gives me 6. Then what I can do is I can divide the top fraction by the bottom fraction. And the way that we do that is you take your top fraction, 3 halves, and you multiply it by the inverse of the denominator. Anytime we divide by a fraction, we multiply by the inverse. Now let me prove that to you. Because again, that's a math trick that went unexplained right there. If I have, let's say 4 apples and I divide that by a half, okay? So if I gave you 4 apples and I said divide these by halves, how many halves would you have? Well, you would have 8 halves, right? You had 4 apples and you divide it into halves, you're going to end up with 8 halves. So how do I get there? Well, 4, remember 4, any number you can represent as a fraction simply by putting it over the number 1. Okay, so 4 over 1 is how I'm going to represent 4, divided by a half. This is where we get the idea that we take the top number times the inverse of the bottom number. So 1/2 becomes 2 over 1. When I multiply across the top, that's 8. I multiply across the bottom, that's 1. 8 over 1 leaves me with the number 8. Right? So that's what we mean. If I'm here, okay, this is a lot harder to, you can visualize 4 apples dividing it into halves. What's harder to visualize is that you have 3 halves of an apple that you're dividing into 17/6 of an apple, into 17/6. That's a lot harder to visualize. And so then utilizing the math behind how we get there is we're going to take the same principle. We're going to take the numerator, 3 halves, and we're going to multiply it by the inverse of the denominator. Inverse means that you flip the fraction. So 17 over 6 becomes 6 over 17. So now we have two fractions that we can multiply. So we can multiply across the top. 3 times 6, that's 18. And then we can multiply across the bottom. 2 times 17, that's 34. Both of those are even, so I already know that I can divide both of those by 2. 18 divided by 2 is 9, and 34 divided by 2 is 17. So the final answer here is 9 over 17. Now that was a little hairy. I meant to do an easy one, and I think I did not. But all of the order of operations, we did the same. What made this one a little bit more complicated is the fact that we're dealing with fractions. All right. Any questions on that? All right. Let's do one more. And what I will do this time, this will be kind of fun. I'm going to write out the problem, and then I'm going to let you figure it out on your own. I'm not going to do a fraction one, don't worry. I'll do one with regular numbers. So whoever passed out thinking they were going to do it with fractions, you can wake back up. I'm going to do a regular one with numbers, and then before the end of the class, then I'll show you what the number is that you should have gotten, okay? So this is your problem. All right, so this is the quantity of 10 over 2 raised to the second power plus 6 times 3 plus 1 minus 4 divided by 2. I'll give you a couple minutes here, and then I will show you what the answer is. And if you get it done and you just want to message me privately, then I'll let you know whether or not you got it right. One person get it. Good work. And another person get it. Good work. And a third person get it. Good work. All right, and the answer you're looking for is 42. 42. All right, that is our time.